Check out this ESP32 design from Raul Rodriguez for a smart water pump controller. Now this design is available on OSHW Lab. Check out the link in the description. You can see here that it looks pretty cool. You can see here we have a nice 3D printed enclosure with the switch poking through. Only thing here is you do have exposed connector for your AC input. Consider moving that inside the enclosure, maybe using a screw terminal block. This design is in easy EDA, so don't be surprised when some Chinese guy steals your intellectual property. Next, inside your schematics, I do see AC inputs and outputs, and I didn't think you would go the module route for AC to DC conversion inside the schematics, but you did use the HLK PM03 module. That is a good choice for this design. Next, on U1, it does look like you're using USB to power up this device for programming, which is fine, but I think you have a fixed output 3.3 volt LDO here as your power supply, and I don't know what the part number is. It's always good to include that in these designs. Here it just says TPA, and I don't even know what TPA is supposed to be.
What the hell is even that?
Next, on your USB connector, here you have L1 and L2 right on the data lines. And what are these components? They're ferrite beads.
Just say no.
Seriously, don't do that. There's absolutely no reason for you to do that. All you're doing is creating loss at high frequencies on these lines. And remember, these are digital data lines. They do need power at high frequencies. If you have an actual noise problem, then you should solve it at the source rather than just throwing some ferrite beads on your data line. Sometimes you have common mode noise that comes in through a cable, and if you do have common mode noise coming in through a cable, you can always add a common mode filter IC that is specifically rated for USB interfaces. You only have ground below the digital section and you don't have ground anywhere else. Here you actually have some of these lines routing out over to your AC-DC converter and to your relay, and those lines are going to have higher EMI susceptibility. Really, a better solution is to just pour ground everywhere in this design and make sure you apply the right clearances to those AC lines up at the top half of the board. Next, on your ESP32 module, here I can see that you only have one small via right there in that central pad array underneath the module. But what you should have is multiple vias, and you should be connecting all of those pads together. In order to solve this, just put some vias in between the pads, put a small copper pour that connects all 9 of those pads together, and that's going to give you good thermal dissipation into the ground plane on the next layer. Next, the spot where you actually want to have conductive noise filtering in this design is right here on the AC input. You should put an EMI filter on the input where your AC power comes in, and that's going to remove conductive noise that could come into the design from the mains connection. I'll show you some examples of these EMI filter circuits in another video, so make sure to subscribe to the channel. Want to have your ESP32 design reviewed on the channel? Find me on LinkedIn and send me your design files.